Hey, this is Mrs. Levine. I wanted to go over a question on the test, and I felt it was easier to show you rather than try to write it out. So we're going to go over the question about how does the large-scale melting of Arctic sea ice affect deep water currents? This is on the Unit 2 test. I think it's the very last question. So let's go over exactly what happens. Okay, so let's talk about density first. Okay, so the density of salt water. So we have two glasses here, and they both have the same amount of salt and the same amount of water. Okay, so if we were to talk about density, so how compact an object is, so how much stuff is in an area. We've discussed this by mass over volume. So mass divided by volume. So I have it set up. We have two glasses. There's 10 grams of salt, so that's the mass, and there's 25 cubic centimeters of water. Okay, so the actual amount or the actual density of this glass of water is 0.4 grams per centimeters cubed. Okay, so these two right now are equal. Now, let's say I take the second glass of water and I double the amount of water in it. So now instead of 25, it's 50 centimeters cubed of water. Okay, I didn't change the particles. There's the same amount of salt in it. So if I was to take that equation and then change the amount of water, it changes to 0.2 grams per centimeter. 0.2 grams per centimeter cubed is the density now of this new water. So the density is lower because there's less particles. It's less compact now. Okay, they have more room to move instead of being really close together. So right here we can see that this glass has a lower density than this glass. So let's move on. Okay, so let's talk about how this actually affects what is going on with the Arctic sea ice. Okay, so let's see how this changes. So right now we have the same density. So again, this one's 0.2 or point. It didn't copy. Okay, so we have the 0.2 right here, and then we've got the 0.4 over here. Okay, so obviously when water gets colder, it forms ice. Well, when you form ice, it leaves the salt. So only the fresh water is removed from the ocean water. Okay, so the salt is actually left there. So if we're in the Arctic and water is obviously cold enough to freeze, it's going to build icebergs or sea ice. So what that's going to do is it's going to take the water, so let's say it's in this container, it's going to take the water and it is going to form the iceberg. As it forms the iceberg, the water level is going to decrease because the water is going to the iceberg, which then is causing the density of the water to increase. So no longer will it be 0.2. It could go back to the 0.4. So let's say it took all that water back. Okay, so now we've just compacted the amount of salt again. So now we've decreased the density again, or increased the density again, because we've compacted all that salt together by removing the water to build the iceberg. So same thing happens. Iceberg melts, and it's going to increase, it's going to increase the amount of fresh water again, lowering the density back down. So now these particles have more room. Whoops. They have more room to float around in their water environment. I can't pick them up. So they have more room to float around. That object has now gone from being compact to more loose, which means the density is lowered again. So by the icebergs melting, you're adding more water, fresh water, into the thing, and you're lowering the density of the water. So what does this mean with the currents? So what this means is deep water currents, they are formed by warm surface currents traveling to the cold water of the Arctic. When the surface current cools down, so the surface current cools down. When it cools, the water becomes more dense. So cold water becomes more dense because those particles are kind of coming together. Okay, becomes more dense. When the dense, cold, salty water, okay, because water is being pulled out into these icebergs or sea ice, that dense water becomes extremely salty, and it's heavier now because it's got more particles. The water sinks and it pushes the current. So think of like a roller coaster. As it's coming down, it's pushing the rest of it, okay, or air. So it's pushing it around, and it pushes that current around the world. So if that deep salty water isn't sinking, the current can't move, okay, because there's nothing pushing it. So let's look at a picture of the currents, okay. So this area right here is where the ocean current, where that current starts. So this is where the current starts, up here in the Arctic. So this is where the start point is, where the warm water comes up, cools down up here, okay, and it sinks right here because it's getting super cold. So this is a lot of Arctic sea ice up here. So the water sinks, it cools, sinks down, and it starts that current going around. So because that current is so deep, think how deep the ocean is. It can be extremely, extremely deep. It doesn't warm up as it's going through the Arctic or around the equator where it's super warm. Only the surface water heats up. So it's so deep that it does not get affected whatsoever. And it comes down, and again, right here near Antarctica, that water gets recharged, okay, because again, the water's freezing along here, causing it to sink again, and it's recharging this current, again, pushing it. So the current will continue around. It splits right here, goes up the east side of Africa, and it starts to warm up again. It's coming up to a continent. Okay, so it's coming up to one, and it's going to be pushed up because the land, it's not as deep anymore, so it can't go across the bottom of the ocean, so it's actually going to be warmed up. And again, same thing here, goes up, it's starting to get warmed up, and over in here it's warm, so then it becomes a warm surface current. That current comes back around. Look at the Caribbean, that's super warm water. It's because of this current coming through, and it comes back up to the Arctic, freezes, and goes back down again. So to recap, you have to be able to explain how and why the density changes and how that affects the current. So why is the density changing? Okay, so why is the density changing? Think of the Arctic and what's happening right now. The sea ice is melting. So what's happening with the sea ice melting? What's it doing to the density of the water? And then how would that affect this current? So if the current needs dense water to sink, How does that adding fresh water from the ice melting affecting the ability of the current to sink? Okay, so I hope this helps. Let me know if you need any more help. Remember, there's help sessions Monday and Friday at 11 a.m., or you can catch me after class and I can help explain it more.